Hello everybody, I'm Neeraj Garg, a faculty at Narayana and teaching here since last 10-12 years. I did my post-graduation from IIT Kanpur and today I'm going to discuss JEE Mains 28th morning shift paper. Okay, so let us start with the question paper now. So here comes the first question, that is 26th question. As we can see, it is due to presence of an EM wave whose electric component is given by E is equal to 100 sine omega t minus kx Newton per coulomb. A cylinder of length 200 centimeter holds certain amount of energy. First thing is that length is given to us 200 centimeter. Inside it, total amount of energy is given. He's saying some energy. If another cylinder of same length but half diameter then previous one holds same amount of electromagnetic energy, the magnitude of electric field of the corresponding EM wave should be modified as. I hope we can understand from the question itself that in these two cases we are giving the two cylindrical containers having same length. So as you know, electromagnetic energy is given by E is equal to, or if I write notation by E, or I write simply energy over here, the energy is equal to half of epsilon naught into E square into you're writing your volume, that is there. In this case, volume we can write as the cylinder is being given. So we can say half of epsilon naught into E square into pi r square into length. Now we can understand from this question, as we are saying, if another cylinder of the same length but half the diameter. Let me write energy as if I write it is by, suppose I write it by U relation. So U is my denoting your energy. So let me say U in the first case is U1. Energy I can write, or rather the electric field intensity, the magnitude in the question is given to be 100 over here. So I can consider it as E1. Length is given to be same because they have got the same length, but diameter is given to be different. So I choose this as my variable R1. Secondly, if you write U2, obviously you can write it is going to be half of epsilon naught into E2 square into pi R2 square into L. This is the value. So if you compare these two, he is saying these two energies are going to be equal. So I can say U1 is equal to U2. What does this say? All factors are going to cancel out here even. So I can say E1 R1 is equal to E2 R2. I hope it is very easy for you to understand. Now we are writing R2 is going to be half because he's saying but half the diameter than the previous one. So I can say it is going to be E2 into R2 is going to be R1 by 2. You can write it now E1 into R1. I hope that is clear to us. R1 gets cancelled out. So what we are writing, E2 is simply nothing but what? 2 times E1. You are considering the same cylinder, so you can understand that initially the energy is given to be E1 is given to be, here we can write it is rather, I can write this energy, this energy E vector is given to be 100 sine omega t minus kx. This initially, this energy I can write it is E naught 1. So this is all maximum energy we are writing. So this is going to be replaced by 2 times E1. So what is my wave represented? E2 I can write is nothing but what? If you don't worry about, I'm writing E2 maximum. If you want, you can write E1 maximum. These are my E2 vectors. So E2 can be written as something. So E2 is equal to 200 sine omega t minus kx. That means I hope you can easily understand. Yes, first is the right option for this given question. Okay, hopefully that should be clear to all of us. Now let me go for the next question. Now the next question, that's what we raised 27. Here we are saying for a, you can see this question. We are saying for a particular ideal gas, which of the following graphs represent the variation of mean squared velocity of the gas molecules with temperature? In this question, what we are writing, it is a mean squared velocity. So we should understand that mean squared velocity is nothing but the square of the root mean squared velocity. Now we know VRMS, root mean squared velocity, is under root of 3 RT divided by molecular weight m. Now in the question he is saying for a particular ideal gas, he is saying you have to write a relation between the mean squared velocity and the temperature. So if I write mean squared velocity, so VRMS, as we said, here you're writing VRMS is nothing but square root of mean square velocity. So since we are writing Vrms square, so if I write Vrms square, that should be proportional to temperature, because for a given gas R and M are going to be constant factors. So Vrms square is nothing but what I can say, it is nothing V mean square. So V mean square is proportional to temperature. Since V mean square is proportional to temperature, meaning is what? It is going to be a straight line. That means if it is Y is proportional to X, if Y is taken along this mean square velocity, so that means option 2 is the right answer. So we can go for option 2 here as the correct option. I hope that is also a very simple question as far as this paper is concerned. If I go for the next question, here he is saying which of the following circuits has the same output as that of the given circuit. I hope this is also very easy way of thinking. If I write it here, just see in this case, now I'm writing this, you see this paper here. I'm writing A factor is this here and this B is there. B is denoted by a not sign here. Before going for this upper one, let me say this upper is this one. This is logic's gate. So this is going to, you understand, this is going to be an AND gate here. Similarly, you can understand this is going to be an AND gate over here. And this is what you can say, it is OR with a not out there. That means this is going to be your NOR gate over here. Is that okay? Now I see if I write this A, B, the input over here is what you are writing A, B bar. So if I write this output here, so from the first, if I write what is my output in this case, so I'm coming for the first output here in this situation. For the diode, let me say for this logic gate over there is the AND logic gate. So I can say it is upper one. So for upper one, the output is going to be here. If I denote it, if you just see in the diagram itself, so I'm just denoting it here itself. This output, if I'm writing, is going to be nothing but what? A dot B bar, because AND gate we understand is A and B means A dot B. So I'm writing A dot, but B is coming over here is B bar. So I can say it's going to be A dot B bar. Similarly, if you see the second AND gate here, in this AND gate, input and output, they are coming A and B, they are coming as it is. If A and B are coming as it is from here, you can understand that means this output I can write is nothing but what? A dot B here. And if it is A dot B and your OR gate, I hope all of you understand. If I write A or B, so if I'm writing A or B here, so that is nothing but what? You write A plus B over there. If I'm writing A plus B in this situation, so what you are going to get in this situation here? If I consider these two inputs in this way, first input I'm getting at is A dot B bar. I hope it is easy only. Then I am writing plus second output we are getting here. That second output is here. That is what you are getting, this A dot B. So I write now A dot B. And that is going to be added together. So it is going to become OR. But output is going to be now NOR of this. So I will say now Y is becoming A dot B bar plus A dot B whole bar. That simply indicates what? I can say A is common from these two. I can write it is going to be B bar plus B. So it is B bar plus B. So I just, this is not bar. So I'm writing B bar plus B whole bar. And that makes it B bar plus B. We know very well that B bar plus B is going to be 1 only. So I can write it is going to be A dot 1 whole bar. Or simply I can say A dot 1 is nothing but what? A. It becomes A bar. And A bar meaning is what? It is indicating not A. So that means A not A, that means A is becoming knotted circuit. And you know, whenever the diode, the two inputs are same and there is an NOT gate, that means it is indicating your NOT. So what is this now? So I can say this option 4 is the right option. So here for this question, option 4 is the right answer. That is also a very simple question if we use the De Morgan's properly. Now let us go for the next question now. See this question, what they are saying, let us read this question first carefully. Here we are saying a Carnot engine E is working between the two temperatures 473 Kelvin and 273 Kelvin. In a new system of two engines, engine E1 works between 473 Kelvin to 373 Kelvin and engine E2 works between 373 and 273. If eta 1, 2, eta 1 and eta 2 are the efficiencies of the engine E, E1 and E2 respectively, then we are asking what is the relationship between eta 1, 2 and eta 1 plus eta 2, something like that. So if you see the options, we have to understand what is eta 1, 2. You know, in case of Carnot heat engine, first of all, let me say for Carnot heat engine, the efficiency is given by something like 1 minus T2 upon T1. I'm coming directly for the relation. So as we know, the efficiency is going to be 1 minus, if I write T2 divided by T1, T2, 2 stands for sink temperature, that is the lower temperature, and 1 you know very well stands for source temperature, that is a higher temperature. That means if I write what is my efficiency of the engine 1, this is denoted by N12. So if I write N12, it is going to be 1 minus the temperature given over here is 473 and 273. That means my temperature of sink is going to be 273 divided by 473. If I simplify, this is going to give you something 200 divided by 473. I hope this is very easy for you to understand what is my efficiency of the engine E. Similarly, if you write here, you write because E1 works between these two temperatures 473 and 373. If I write these things, so I can understand, I can write for you, that is N1 is going to be 1 minus again the temperature of sink divided by temperature of source. Now working temperatures you are saying is 473 and 373. That means I can write it as 373 as my temperature of the sink divided by 473 as my temperature of the source. What does this give? It is going to give you 100 upon 473, that is this value of N1. Similarly, if I write what is my efficiency of the second engine E2, in case of E2 is saying working between these two temperatures 373 and 273, again is much simpler to answer. It is 1 minus 273 upon 373. This becomes nothing but what? Again 100 upon 373. That becomes this temperature range. The moment I am writing this, I hope he is asking some relation between N1 plus N2, and obviously if I write N1 into N2 and if you compare, that means 2 is not the right possibility. So I have to check it with eta 1 and eta 2 sign. Let me write now, if I write N1 plus N2, that becomes 100 upon 473, and then I'm writing again 100 upon 373. It gives a very obvious picture. If I write N12 here and I break it in this manner, I split in this way, 100 divided by 473 plus 100 divided by 473. Here my denominator is going to be 473 in this case, and but if you see here in this N2, it is going to be 373. This denominator is becoming a smaller quantity. That means this quantity is going to become a larger quantity. That means what we can understand from here, that N1 plus N2 definitely is going to be more than this N12 picture. So instead of, you can say it is N12 is going to be less than N1 plus N2, or efficiency, some of the efficiencies of the two engines E1 and E2 is more than the efficiency of the engine E. So that means now option A should be the right answer. So option A is right one. The one is the correct option. I hope that is also a simple question in this paper, so not a very difficult one. Okay, now let us proceed for the next question, question number 30. This is more or less is a theoretical question, and in this theoretical question what he is giving, so consider the following statements. So we have to answer depending which statement is right or wrong. So choose the, lastly they are writing, choose the correct answer from the options given below. The options are given above, no issue. So here we are writing A is surface tension arises due to extra energy of the molecules at the interior as compared to the molecules at the surface of liquid. You know very well, in case of the liquid, if I say, if you talk about the region of molecular activity, then region of molecular activity is simply a region in which you can say a molecule is going to experience the force by other molecule or is generating some force on the molecule within the region of molecular activity. So if I consider my molecules which are lying on the surface or which are somewhere within the region of molecular activity, suppose I say this is my radius of the region of molecular activity, if I denote it by R naught. So I hope you understand all these molecules which are lying within this range of R naught will experience a net downward force. So that means definitely here the energy is going to be more. So I can say as option A is saying, so in this region here the molecule which is here will definitely be experiencing more force in this manner because this part is going outside. So if I consider this is going to be pulled somewhat in the upward direction, this is going to get some more force in the downward direction. What I am trying to explain, he is saying in this statement 1, surface tension arises due to extra energy the molecules at the interior. This word interior, which is what is written, is wrong here. It should be, if it is exterior is okay, as compared to the molecules at the surface of the liquid. The molecules which are in the interior will not experience any force because they are equally surrounded by all the molecules, so the net force on this is going to be 0. It is not experiencing any force, there is no energy. That means obviously this option A is not the right answer, is a wrong option. If you go for the option B, here we are saying as the temperature of the liquid rises, the coefficient of viscosity increases. If you look for the viscosity, what is the coefficient of viscosity? If you go by the viscous force, then we say since viscous force F is equal to eta into A into velocity gradient. I'm not writing a minus sign, that depends on our sign convention, what you're considering. If you go in the upward direction, the velocity is decreasing, then we write a minus sign and all that. So that is not an issue. If I write F is eta A into dV upon dy. Now the thing is, as the temperature of the liquid rises, the coefficient of viscosity increases. If I say here, so how can you say this so? Because the moment I say, if I'm increasing this temperature, the temperature if is being increased, then dV upon dy is going to become what? Is going to become a smaller quantity, because velocity will become more per unit change in the length, because molecules are running, because I'm increasing the temperature, so they move very conveniently. So you can say as the temperature of the liquid rises, the coefficient of viscosity, so this dV upon dy factor is going to be a decreasing quantity. What we can say, that means with the rise in the temperature, if I'm writing, so my dV upon dy factor is going to become a smaller value. If you look for here, so what I can say in this factor, viscous force is becoming less. If I say my viscous force is becoming less, that means my coefficient of viscosity is also becoming less. So here I can say this means that B is also not the right answer. Now if you go for this here, as the temperature of the gas increases, the coefficient of viscosity increases. But obvious, if I'm increasing the temperature of the gases, is a very interesting point here. If the temperature of the gas is being increased, then the randomization of the molecular motion is becoming more and more. If randomization of the molecular motion is becoming more and more, that means what? Your more force is becoming, particles will experience more resistive force to move along. That means my viscosity will increase. That's what he's saying, that C is the right answer. So that means as the temperature of the gas increases, the coefficient of viscosity increases, is absolutely correct here. So I can say yes, C is the right answer. If you come for the next option, D, here we are saying the onset of the turbulence is determined by the Reynolds number. You know very well, we know. So from here, we know one thing, that Vc is equal to K eta upon rho into diameter of the tube through which your liquid is flowing. From here, we know this K is a Reynolds number, and the critical velocity is deciding whether my flow is turbulent or streamlined. The turbulence and streamline factor is no doubt decided by Reynolds number. So it is, if you say Reynolds number is going to be less than 1000, generally we say that the motion is said to be streamlined. Is more than 2000, we generally speak, then we say the motion is going to be turbulent. That means yes, the onset of the turbulence is determined by the Reynolds number, is the right answer. In is next, we go for the next option. So here this is next statement, sorry, that is E, in a steady flow two streamlines never intersect. That too absolutely correct. Here if I say the streamline, if the two lines are going to intersect, that means for a particular particle you have got two velocities, and at one point, rather one particle cannot have two velocities altogether in two directions. That means this is not possible. So here we say in a steady flow two streamlines will never intersect. If they are intersecting, I'm negating this statement. If they are intersecting, that means what? Velocity should be different, but that is not possible. That means what we say, in a steady flow two streamlines never intersect, is the right option, because one particle will have one velocity at a time in one direction. So here we can say that if you see these options, the out of given options C, D, E, this is the second option. That means option 2 in this case is going to be the correct option for this question. I hope you got the clarity for this also. This is theoretical question, so we should try to understand what they're asking, how the surface tension is changing with the temperature, how the viscosity is changing with the temperature, and on what factors my surface tension is depending upon. So we try to understand. Now let us go for the next question, that is question number 31. Here we are saying two capacitors C1 and C2 are connected in parallel to a battery. First thing, C1 and C2 are connected in parallel to the battery. That means both of these two capacitors are going to have the same potential difference across them. Charge time graph is shown below for the two capacitors. The energy is stored with them are u1 and u2 respectively. Which of the given statements is true? As if you see from this graph itself, so if I come for the graph, so if you look for this figure, so in this figure if you see, here you see this Q for the capacitor 2, this is 2, and if you look for this, the maximum charge that is acquired by the second capacitor is going to be more. So let me write it is Q2 maximum somewhere here. Similarly, if you see C, I can write this is going to be Q1 maximum is going to be like this. Okay. If you write in this manner, because see here, I'm saying there are my two capacitors are there. So these two capacitors are connected in this manner. That is one capacitor. And then you're writing this the second capacitor. As they are saying these two capacitors are connected in parallel, let me write C1 and let me write C2. You can understand it very, very easily. The potential difference applied here is going to be V. What are the charges, the maximum charge is going, this capacitor is going to acquire at a steady state? If I say, because this the graph is showing at a steady state, if I write Q is equal to Q naught into 1 minus e to the power minus t upon RC, you all are well aware of, and then I am writing here as this steady state has reached. So at a steady state, this Q2 is going to be maximum. So here I can write at a steady state, if you write, so at a steady state, the maximum charge, that is Q maximum acquired by any capacitor, is going to be C into V. Here from if I write, and the diagram is indicating that Q2 optimum is going to be more than what the diagram is showing, Q1 optimum. Optimum charge I am writing at C into V. So what we can say from here, C1 into V is going to be more than C2 into V. That simply gives you a clear picture. C1 is going to be more than C2. The moment I am saying C1 is going to be more than C2, you can see that is 2 is the right option. As I write C1 is going to be greater than C2, also you write what is my energy? Energy you're writing is half C into V square. Again, as the question is asked in such a way that V remains constant, that means I can straight away say from here that energy of the capacitor in this situation is proportional to its capacity. If C1 is more than C2, that simply implies that U1 should also be more than U2. If you see this here, I'm sorry, I just changed this notation. C2 is having more, so 2 is more. So if 2 is more, so I can say I have just changed it here. It is C2 and this is going to be C1. So it is going to be C2 is going to be more than C1. So just a moment. I just correct it. So it is going to be C2 because we are writing Q2 is more than Q1. Q2 is C2 into V, C1 into V. I hope you understand this, what I'm saying. This is just a mistake from my side. Now you can write C2 and this is going to be C1. So what I write C2 is going to be greater than C1. Similarly, if you write here, so once I am writing U1 and U2, U is proportional to C. I hope there is no confusion in this. So again, as I am writing now, C2 being more, C2 is Q2 is going to be more than Q1. C2 is going to be more than C1. If C2 is more than C1, then what I can write from here, this is U2 is going to be more than U1. Can you see this option here? So yes, we can see it in the option number 3. C2 is more than C1 as well as U2 is more than U1. That means according to me, this option 3 should be the correct option. So 3 should be the right answer for this question. I hope there is no confusion because we are writing it is parallel. As we have written, the graph is indicating second capacitor is going to acquire, I think you can see it here in this case, the C2, this is second capacitor is going to acquire the more charge here. So this is Q2 is more and this is Q1 is less. Okay, so I can say C2 is more than C1. So it's again very straightforward question, so not an issue. So that is also a simple question for us. Now let us come for the next question. If you see this question, question number 32, the center of mass of a thin rectangular plate, figure is shown here, with sides of length A and B, whose mass per unit area varies as sigma is equal to sigma naught x divided by AB, where sigma naught is given to be a constant factor. So what he is saying, if you are asking, okay, what is the center of mass? You know, center of mass, how do we define the center of mass in this situation? If I say center of mass, see, one thing is interesting here to see. If I look for this situation, in this figure you can say sigma is given to be sigma naught x divided by AB. That is indicating it is varying with x. If sigma is varying with x, but there is no sign for y, that means sigma is constant in y direction. If sigma is constant in y direction, that means we can consider the mass distribution in y direction is going to be uniform. Instead of we can say, we know this thing, if there is a uniform mass distribution, then we can say the center of mass in y direction will definitely be at a distance of b by 2. So if I write y center of mass straightforward, so I can choose this thing here, y center of mass in y direction, I'm writing it is y center of mass should definitely be b by 2. If you want to use your formula, we can get it by using the formula in a very simple manner. I just write it for x, because x, and you know how to write x center of mass. Formula we know very well. It is mass element at some distance x divided by mass element over there. Integrating for the whole area is, or whole length, is going to give you this x center of mass. This is a way of defining how we are defining center of mass. Now if I consider this part here in this figure, with x, let me consider some small element of the sheet at a distance x from here. I hope you got it. And in this case, if I consider this area of this sheet here in this manner, so what is the area of this factor? We can say this area is going to be how much? I can very easily write, let me say this distance is going to be dx, length is given to be b here, so I can write b into dx as my area. If b into dx is my area for this, sigma is going to be sigma naught x upon AB. So how do I write my mass relation? If I write my mass relation here, so this mass relation is becoming, mass is nothing but what? Mass density into area. The mass density is given in terms of area itself. So I write dm is equal to, listen carefully, it is what I am writing, sigma naught into x divided by AB is this sigma into dA. dA we have written as b into dx. This into elemental distance is x. So I write into x divided by whole thing dm. It is sigma naught upon AB into x into b into dx. This is now is my mass. If I write this thing, x is integrated from 0 to, length is given to be a here. So I integrate it from 0 to a. I hope it is easy for you to follow. It is again going from 0 to a. It's damn simple for us to solve. Constant factors we can avoid. This b factor, sigma naught AB all has cancelled. What is left over? It is very easy. I'm getting x factor here, I'm getting x factor here. So what you're going to get now, beta? X square dx divided by, I can write now x dx. So if I integrate it again from 0 to a, we are done with our answer. It is a cube divided by 3. I hope there is no need to solve all such simple things. It is a cube a square upon 2. What you're going to get now? That means it is going to be 2a divided by 3 is now my x coordinate of center of mass. And in this option, if you see, you can see is option number 3. It is given to be 2 upon 3a and b by 2. So y center of mass is b by 2. You can get it in the same manner, dm into some factor in y direction divided by dm in the same manner. So it is going to be b by 2. Directly I write now. So the option correct over here is going to be, third is the right option here. So that means option 3 according to me is correct only. That is 2 upon 3a and b by 2. I hope this should be clear to you again. So again we can say this is not a very difficult one, it's easy only. Let us go for the next question here. So in this question, again it is a representation based question. What we are saying, read again it easily. A sound wave has a higher speed in solids than gases. As such, this question is no doubt is a theoretical question, but if you say to understand these things, okay, if I write the velocity of sound, so I write velocity of sound is equal to under root of bulk modulus of elasticity divided by density. Okay, this question is already been asked in JEE previously also. Here we say if I talk about B and rho, I can explain it very easily that bulk modulus you're writing is going to be dP divided by dV upon V with a minus sign, something like that. If I write bulk modulus magnitude here, so we can say it is V into dP divided by dV. One thing is obvious, for the same change in the pressure, the change in the volume of the solid is going to be less in comparison to the change in the volume for the gas. So here we know, since for same change in pressure, if I write for delta P to be constant, or delta P to be constant, if I consider same pressure, I can write delta V for gases is much larger than dV for solids. So one thing is very obvious, ki here if I write bulk modulus if you talk about the bulk modulus of what is that here? Solid, because gas volume is more, so this is going to be more, and B is inversely proportional for the same change in the volume. Be careful. dP I'm keeping same for the same volume I'm talking about. So I'm talking first of all explaining the reason our gases have higher value of bulk modulus than solids. So if I write B here, the dV for gases being more, I can say B for gases definitely is going to be less than B for solid. That means bulk modulus of elasticity for solid is more. That means gases have higher value bulk modulus than solid is absolutely wrong statement. That means R is wrong. So I can say R is wrong. The reason is not correct here. But if you look for this, as I'm saying V is equal to B upon rho. Now you can understand if you look for B and you look for density variation. As far as the velocity is concerned, no doubt it is depending on bulk modulus as well as depending on the density. Here we have to be careful because bulk modulus for solid is going to be more than the bulk modulus for gases, already we said. Also, density of the solid is going to be more than density of gases. So that becomes an interesting question ki if both of them two are going to be more, so what we can understand? Here we say the effect of this thing. Ki who is a dominating factor here? So if I write for the dominating factor here, so I say the dominating factor is going to be bulk modulus of elasticity. That's why we say if B is increasing in a dominant manner, then the increase in density for the solid. So this B solid is changing in a dominant manner, that we say the velocity in solid is going to be more than the velocity in gases. Reason you have to understand, try to understand this thing. This is a theoretical concept. We cannot explain to that extent here. If B of the solid is changing in a dominant manner, then the change in the density of the solid. So increase in the bulk modulus of solid will be more. Yeah, B of solid is more than the density of this solid here. So you can easily say V of solid is going to be more than V of the gases. That means A is true, but R is false. According to me, again I can say option 4 is the right option. Okay, Vita. So now I hope you can understand it easily. So we should go for the next slide here, next question. So let me go for the next question. Is question number 34. This question is again, it is based on this de Broglie's wavelength, and on this de Broglie wavelength, what we are writing here. You read the question: a proton of the mass mp has same energy as that of the photon of the wavelength lambda. If the proton is moving at non-relativistic speed, then the ratio of its de Broglie wavelength to the wavelength of photon he is asking. Okay, but what it is given, he is saying proton of mass mp has the same energy as that of the photon of wavelength lambda. I can say if you write this energy of the proton, so if I denote it by E only, because in this question also you see, if you see these options, in options they are showing something E out there, but in the question there is nowhere E written over there. So I hope if it is correct, then E should be, we should treat as energy total. So as he is saying the proton of the mass mp has the same energy as that of the photon of the wavelength lambda, so this energy should be taken as E. Then only I can see these options we may have something that E I think is nothing but what? Energy. If you say E is my energy, so E I write equals to kinetic energy of the proton has the same energy as that of this here, so I am writing mass of the proton, so it has got some kinetic energy half V I am considering as non-relativistic speed of this proton, so it is energy. Energy of the photon very well is h nu, or we can write it is hc divided by lambda, because lambda is given to us in this question. As lambda is given to us, so I am writing my energy of the photon hc upon lambda, kinetic energy of the proton half m into v square. Very easy. Here we are saying the next line, we are asking the ratio of the de Broglie wavelength of proton to that of photon. So we are saying ratio of de Broglie wavelengths of the wavelength of the photon. So okay, right now, so if I write lambda, you know very well, de Broglie wavelength lambda is given by h divided by momentum, that is mv. I am talking for lambda of proton. Suppose I am saying it is my proton, so if I write proton here, so I will write mass of the proton into velocity. Lambda of the photon already given to us. The lambda of photon as we are writing is lambda, no issue. He is asking for if the proton is moving at a non-relative speed, then the ratio of its de Broglie wavelength to the wavelength of the photon. That means we are asking lambda of proton to lambda of photon. If I write lambda of proton divided by lambda of photon, very obvious, you're writing here from, it is h divided by mass of proton into velocity divided by 1 upon lambda here. In this question, statement is given as half mp into v square is hc upon lambda. I hope you're getting from here. I can say denominator is mp v into lambda. mp v into lambda, if I take it from here, so this statement gives you what? I write mass of the proton, velocity into lambda. So mp v into lambda, if I'm writing, I hope if I'm writing correct, it is going to be 2 times hc divided by mass already been taken here, v is left over. So I can write mv lambda is 2 times hc upon v. I hope this is very simple calculations. Here I can substitute this value here. So I can write here from this, see this is shown here from. So I write h divided by mpv into lambda, it is going to be 2 times hc divided by v. hs goes out. What I am getting, my this ratio is coming out to be something v divided by 2c. But if you see these options, in option it is giving something E and mass relations are there, but V is not there. That means ultimately we are forced to express this velocity in terms of E and mass of this. And here from we can see it from here easily, because we see this relation, it is saying E is equal to half of mass of the proton into velocity square. So here from if I write one simple sentence, this V is going to be how much? It is 2 times E divided by mass of the proton whole under root. If I substitute back over here in this relation, so that becomes V is going to be 1 upon 2c. Let me take out common, separate here. It is 2 times E divided by mass of proton. If I take 2 inside to get these options, because 1 upon c is taken out common, I take 2 inside. So obviously it is becoming E divided by 2 times mass of the proton. Any option is there, so you can cheat. It is going to be option number 1 here in this question. It is 1 upon c E upon 2 times mass of the proton. That means option A is the right option. So 1 is the right option for this question. I hope this is also very easy and interesting for you to see how simple these questions are. Okay, now I am heading for next question, that is question number 35. Oh, this question is on work energy. So as you can see here, first line, if you read it carefully, it is given to be without friction. Without friction means conservation of energy is applicable. Vertical circular hoop, that means gravity is also considered. He is writing also, as shown in the figure, the bead moves under the combined action of gravity and spring is ideal, is the massless spring. So you don't have to consider the gravitational means potential of the spring, simply elastic potential is to be mentioned. Attached to the bottom of the hoop, it is attached at the bottom. The equilibrium length of the spring is r. That means at this position, the highest point spring already has elongated. If the bead is released from the top of the loop with zero initial velocity, given to be zero initial velocity, velocity of the bead, what is being asked, he is asking what is the velocity of the bead or the magnitude of velocity of the bead when the length of the spring becomes r. Let us see here. I hope all of you can understand very easily. If I say when this, because this distance is given to be r here in this diagram, you see this is r, and if I write from center, then you can say once the body will reach here. And if makes an equilateral triangle, then you can understand, yes, this spring once is reaching to this position here, then this length and this length, if I consider all of them to be equal, so I can say here is going to be r and here is going to be r in this manner. So that means at this position he is asking what is my speed of this body. So if I write this position here, so at this position let me say my velocity of this body is going to be in this direction, say this is v. This is v he is asking in this question. I hope whenever I am writing my potential energy relation, then you know very well that we should choose the reference point, then only we can define my gravitational potential energy. Accordingly, I am just saying let me consider this lowest point as my datum, or I can consider this as my reference line. With respect to this reference line, I can write all my potential energies. In this case, if I write at the highest point, let me write this highest point. Let me denote it over here in this diagram, position number 1. And once I am reaching to position 2, that is when the length of the spring is becoming r. At these 2 points, I am trying to write my energies of the system. Here you say mass is there. So at the highest point A, so I write at point A here. So if I write this thing here, so I am writing at A, rather 1, highest point. Your spring energy is there. there is U spring. We can say it is half K. Already we said elongation is R. So you can write half K into elongation square as the spring potential energy. Kinetic energy in the question is set to be 0. So I can write my kinetic energy at this position number 1 is going to be 0. So I write potential energy at the position number 1 is half K R square. Also, you can say if I consider this to be reference line, my body has got some mass. So my potential energy, if I'm writing gravitational potential energy at the position 1, so that is going to be how much? You can understand it is going to be mg. With respect to this reference line, it is a distance 2r. So I write mg into 2r. Similarly, if I come for the position number 2, here you see in this diagram, if I consider this to be my circle here, and in this case, this body is taken to be here. I hope I'm just trying to show you the diagram here clearly. This is the situation here. And once it is R, it is R, it is R, it is going to be an equilateral triangle. This is going to be 60 degree. The moment this angle is going to be 60 degree, that means now your mass has come to what distance? This R cos 60 is this value. If I write R cos 60, I hope you can understand it is going to be R by 2 in this way. If it is R by 2, that means now with respect to this reference position, where is my mass? Mass is at a distance of R by 2. So if I write at position 2, what is my spring potential energy? Spring energy, as the question is saying, it has come to its natural length. That means there is no potential energy. But if I write my kinetic energy, it is there. So kinetic energy at position 2, let me say, is velocity is v. So I write half m into v square. And then if I write it at this position number 2, what is my spring potential energy? 0. But gravitational potential energy, if I write, so at position 2, what is my gravitational potential energy? Easily you can say mg into R by 2. As the question is saying, these two energies are going to be equal because there is no loss, surface is smooth, there is no friction. So by conservation of mechanical energy, if I'm talking about the conservation of mechanical energy, is saying what? I just write the statement directly, half K into R square. So if I write half K R square plus mg into 2r is equal to half mv square plus mg r by 2. If I rearrange these terms here, I hope you can see it is 2, 2, it is becoming 4 mgr, and is 4 mgr minus mgr if I write it here. So I cancel this 2, I make it multiplied by 2 here, I cancel it by 2 here. So I hope you can see it very easily. It is kr square mg2r minus mgr, rather it is 4r minus this 3 is m also I'm dividing. So I can write, you can see this statement that v is going to be how much bit? It is kr square divided by m. So I write k r square divided by m plus 4 mgr minus mgr, make it as 3 mgr, but m I'm dividing by m, so it will come 3 times r into g. The whole under root is going to give you the velocity of this particle at position number 2. Again, this is a simple question, so not a big one. Okay, I hope you can enjoy this easy way of solving this just by writing conservation of mechanical energy. So again, you can say yes, option number A is the right option for this question. Okay, let us try to proceed for the next question. Keep on enjoying here. So what we are writing, question number 36. As you see, it is a question based on your equivalent resistance, and this is the most simple and the most common question. Most of you all do it in the board level itself. It is simply what we are writing. If you see, find the equivalent resistance between the two ends of the following circuit. Two ends as the dots are given out there. If I am looking for these two ends here, so let me say this is the end number 1 and I say this is the end number 2. If I take these 2 points somewhere here, it is 3 and I choose this as point number 4. You know, this upper wire between 1 and 4 is a resistance less wire. There is no resistance over here. That means the potential of 1 and potential of 4 are going to be equal. So since we are saying 1 and 4 are connected with a resistance less wire, that means delta V. I can say V between 1 and 4 if I write this here. So I write potential difference between delta V between 1 and 4 should definitely be 0. Reason I am saying my R is 0 in between. That means V1 and V4 are equal. So this simply implies that V1 and V4 are equal. Similarly, if you look for 3 and 2, so similarly I can say straight away that V3 is equal to V2. If I say 3 and 2 points are common, 1 and 4 point is common. So I hope if you start looking for 1, 3, 4, so I will put 1 and 4 points, I will put at one end. I will say 1 and 4 are at one end. 1 and 4 are at one end, and then you're writing 2 and 3 are at another common point. So I make 2 and 3 as my commonest point. Now you can say between 1 and 3 there is a resistance. So let me say between 1 and 3 it is 1 here, it is 3 here. Between 1 and 3 there is 1 resistance. Very easy for us to follow. Similarly, I can say between 3 and 4 there is a resistance. So I say there is a 3 point, there is a 4 point. So I can say there is another resistance between 3 and 4. It is given to be R by 3. It is also R by 3. Similarly, if you see what we can say, 3 already we have done. Then you see between 1 and 3, between 1 and 3 we have covered. Between 3 and 4 we have covered. Between 4 and 2 there is 1 or 4 is here, 2 is here. That means there is another resistance between 4 and 2. So I can connect in this manner. It is R by 3. I hope you can understand it is also. So that's why I say these are my 2 points, these are my end points. R by 3, R by 3, R by 3 all are connected in parallel. You know very well 1 upon R equivalent is going to be 1 upon R1 plus 1 upon R2 plus 1 upon R3 in parallel combination. So here I can say what is my R equivalent between these two. It is going to be R by 3 divided by 3 because all three resistors are going to be equal. So what is my answer? It is going to be R by 9. So I'm not giving so much of emphasis. It's very simple. So you can say yes, option number 2 is the right option for this question number 36. So your option 2 is the right answer for this question. Okay, bitte? So this is also very simple question based on electrical circuits. Let us move for the next slide now. Question number 37. Here you read this question easily, carefully, simply. 3 infinitely long wires with linear charge density lambda are placed along the x-axis, y-axis and z-axis respectively. Which of the following denotes an equipotential surface? Wow, this is a good question. He is asking, if you read it very carefully, he is giving you there are 3 infinitely long wires with the linear charge density are given to be equal for all 3 wires, and these wires are placed along x-axis, y-axis and z-axis. Is that clear? He is saying which of the following denotes the equipotential surface. So we have to see what is my equipotential surface. Means we have to look for a surface where my potential is going to be same. So obviously that is what we are going to call as my equipotential surface. How we are going to go for? Let us try to understand this question. First of all, what is my potential? See, because we are asking your equipotential surface, so what is the easy way of solving? Try to find some potential at any point x, y, z in case of this coordinate system. I just draw for you to understand here. Suppose I draw a coordinate system. Let me draw in this way. These are these 3 axes. Let me choose. Try to understand here this thing. Let me say this is some x-axis. Let me say this is going to be my y-axis. And let us try to understand this is going to be your z-axis. What the question is demanding, he is saying along these axes we are keeping 3 infinitely long wires. If I am keeping these 3 infinitely long wires here, so what you can understand, if I say this is one wire, let me say I'm indicating it by red line. Let us try to understand. It is going to go up to infinity. I hope you understand. Similarly, I am keeping another wire here. Let us see. So okay, no issue. So I keep another wire is along z-axis. So this is z-axis. So we are keeping one wire in this manner. All these wires has got same linear charge densities lambda. Similarly, if I say this wire also has got the same linear charge density lambda here, so this is lambda, it is going to get some same positive charge here also because they are not changing even the nature. Similarly, if I consider this last one here, this wire, so let me say the wire that is what I'm keeping along y-axis is going to be something like this. If I say this is going to my origin here, and I choose this point at something like x comma y comma z, and if I want to find what is my potential at this point x y z, because we have to find a surface, and surface means we have to find some relation between x y and z, then we can define yes what is my surface over there. I will try to find now what are the potentials because of this infinitely long wire at this particular point x y z. You know very well Because in case of electrostatics, the electric field intensity due to infinitely long wire. So if I write since E due to infinitely long wire, so if I'm saying this is going to be infinitely long wire, so this what by Gauss law also we can write E is equal to 1 upon 2 pi epsilon 0 into lambda upon r. R is the distance from perpendicular distance from the wire, and this is what again E is equal to minus dV upon dr. If I'm writing from here, so what does this say? dV is equal to minus times 1 upon 2 pi epsilon 0 lambda upon r into dr relation. If I want to integrate it here, so let me say my reference potential is somewhere at some distance r naught, and let us say the potential is going to be 0 at some reference position r naught. Similarly, I say I want to find my potential at some distance r, so let me write V at some distance r. Here be careful, this r is now my perpendicular distance from this wire. Okay, here we are writing this thing, so if you solve this thing, so we are getting V is equal to 1 upon 2 pi epsilon 0, it is lambda is there into log of r relation, so I can say log of r divided by log of r naught, something like that. If you say with a minus sign here, so what should I write minus here? The one thing is there, if you write with respect to this wire, as higher potential to lower potential, if we are moving, so as you write in the direction of electric field intensity we are moving, then potential keeps on decreasing. That's why I'm getting this is going to be a negative value over here, not an issue. So dE is written as minus dV upon dr. If I write this potential as magnitude is concerned, no problem, let it be in this manner, no issue. So if I write this is going to be here, it is r upon r naught, or if you take minus inside, something is there. So I'm getting my potential in this manner. I can express this V in this manner, some constant into, rather constant minus or something, lambda upon 2 pi epsilon 0 into log of r. I'm putting log r naught as some constant values because some r naught is my reference position. If I consider for all these three wires with respect to origin, then reference point is taken to be same somewhere. So V is going to this, r is going to be my perpendicular distance from the wire. If I choose my wire along x-axis, so that makes it interesting here. What is my potential because the wire kept along x-axis? So if I write potential due to wire along x-axis, so I denote it by Vx for the time being. So Vx means wire along x-axis. I'm repeating. What is my perpendicular distance from this wire here? So I have to see this distance now carefully, see. And this distance, definitely I am writing this distance is going to be along x-axis, this distance along, this is what I am considering my z-axis, this is going to be z. This is what I am considering as my y distance here. In this case, if I consider from here to be y, that means this is going to be y. How much is my perpendicular distance? Very easily we can understand it is going to be y square plus z square relation. That means if I am writing my value over here, so what is my potential? I can write some constant factor here. I'm denoting by this minus something lambda upon 2 pi epsilon 0 into what I'm writing here this. See, one thing I will mention here, one point. As I'm writing E is equal to minus dV upon dr, you may have some confused like why I'm getting this a minus sign here, because it is a positive charge, so my potential should be a positive value, so we don't have to bother about this relation. So I will be writing this is going to be nothing but because I'm writing V because of my positive charge, you take it to be positive. So even if I write this constant sign here and let it be, so you have to understand this why I'm writing, because potential is because of positive here, some constant factor will come. I'm writing E is minus dV upon dr. E, as I said, if I write this here, positive charge is here, electric field intensity is in this manner, this is higher potential, this is lower potential. Some way if you're considering reference position here, the R naught is going to be more than R. So if R naught is going to be more than R, so it is definitely going to be R upon R naught is going to be some negative value. If it is going to be negative value, that means I can put as R naught upon R like now. So if I'm writing R naught upon R, it will become a positive value. So don't worry about that. So I write V is equal to K, something like this. I'm writing my V in x direction. So if I substitute in this manner, let it be log of R. R distance is going to be how much? Under root of y square plus z square. This is what I'm getting some relation because of my potential kept along this axis. So don't worry, as I said here, I'm writing V is equal to minus this. I'm writing it is going to be R upon R naught. R naught I'm saying is going to be more. तो I should write always as R naught upon R. So R naught upon R लिखेंगे, तो I am writing it is going to be with here. So I write R naught, put a plus sign. So I make it as R naught first. Just see here, it is what I'm making it positive, R naught and R, not a problem. I am writing it is simply, so that's what I write K something, some value. It is going to be some larger value. This relation will definitely be coming out to be a positive value. So don't get confused with this negative sign here. Okay, I'm getting something like negative. It's not like that. It is log R naught is going to be more. So I'm getting this factor. So I'm just showing it here in this way. I'm writing constant minus this factor. I'm writing lambda upon 2 pi epsilon log of y square plus z square. I think there is no issue. Similarly, if I write what is my potential because of wire kept along y-axis, if I choose my wire kept along the y-axis here, so what is my perpendicular distance from this here? So this is going to be my perpendicular distance for this point. And this perpendicular distance, if you see, I'm getting this perpendicular distance. Here is my x-axis, here is my z-axis. That means this distance is definitely going to be x square plus z square somewhere here. If I write this v, so I will be writing something, my same constant factor will come minus something lambda upon 2 pi epsilon 0 into log of what I am going to get here is under root of x square plus z square will come. Likewise, if I write, I can write my v due to the wire kept along z-axis is going to be same constant something minus lambda upon 2 pi epsilon 0 into log of under root of x square plus y square. So if I write my total potential, so what is my net potential at position x, y, z? I can add all these things. It is going to be another constant here. Let me write something k dash minus what I am writing here. It is lambda upon, if I take out root also, so lambda upon 4 pi epsilon 0 into log of y square plus z square plus log of x square plus z square plus log of x square plus y square. This whole thing will come out here. As this question is saying, it is log of a plus b plus c is nothing but what? Log a dot b dot c. So I can express in this manner. It is going to be something k dash minus lambda upon 4 pi epsilon 0. I can express as log of, it is x square, I'm just putting in this order, x square plus y square into y square plus z square into z square plus x square. As the question is saying, this is going to be my equipotential surface. That means this V net should be a constant factor. If it is going to be constant for all values of my, some values for x, y, and z on this surface, so what we can say, if it has to be constant, that means this factor has to be constant. If I write this factor is going to be constant, so I'm getting it now, x square plus y square plus z square into z square plus x square is going to be constant, and that indicates what is my equation of the surface. So that is an interesting question, no doubt. So here we have to be careful. He is asking equipotential, so potential on that surface should be constant. So I'm keeping my potential of the surface is going to be constant here, from where it is obviously evident from here, x square plus y square plus z square. That means I can say option 2 is the right option for this question. This one question is good question in this paper. So we should try to understand how to find the potentials due to infinitely long wire and then sum it up. You can understand very easily. Let us move for the next slide now. The next question is question number 38. So this is a question based on the ray optics. Here what he is saying, a thin prism P1 with angle 4 degree made of the glass having refractive index 1.54 is combined with another thin prism P2 made of the glass having refractive index 1.72 to get dispersion without deviation. What the question is saying, we want to get dispersion without deviation. If I want to say, in case of a prism, how do I write my dispersion and how do I write my deviation? He is saying there is no dispersion, but get dispersion without there is no deviation. Angle of deviation in a prism is given by, so if I write directly again, because this is a very simple question again, angle of deviation, you write delta is equal to prism angle A into what is the mean color. Generally we write mu for mean color, that is if we consider it to be yellow color, so I can write mu y minus 1 as my deviation. So delta is A into mu minus 1 I can write. If delta is written in this manner, if you say there is no dispersion I'm sorry, there is dispersion without. If there is no deviation, that means two prisms should be kept in the inverted manner. If I keep one prism in this manner and I keep my another prism in this manner, let me say this has got some prism angle A1, let me call this angle as A2. As prism angles are small, this formula is applicable. So delta is A into mu minus 1. This is what we write for a small angled prism. If I am saying it is for a small angle prism, it is given to be 4° only. It is small angle. Delta 1 in the first prism, if I am writing light is coming somewhat here, it may have some dispersion, but if I write this is going to have no deviation. So I hope you should understand it is going to deviate in this manner. And then I am writing there is some dispersion is there in the light, but finally if I consider my mean ray in the situation, let me draw some mean ray here and let me write some mean ray here, and then it comes out in this manner. If I consider this ray is coming in this manner, then he's saying these two rays should definitely be parallel. If these two rays are parallel, that means deviation in one and in the downward sense. With respect to this, there is one deviation. With respect to this, there is another deviation. So I can call it as delta 2. I can call this as my deviation number 1. You understand delta 1 and delta 2 are in opposite directions. So what we can say, since there is no deviation, since no deviation, so no deviation is indicating what? 0 is deviation, delta 1 minus delta 2. I can straight away write, therefore delta 1 is equal to delta 2. What we can say, it is A1 into mu y minus 1. So I am writing it here. So A1 into mu of the first minus 1 is equal to A2 mu of second minus 1. First prism has given to be 4°. Mu 1 minus 1 is going to be 0.54, 1.54 minus 1. So I can write directly 0.54. I can write A2, second is given to be 0.72. So I can write directly again 1.72 minus 1 is 0.72. So here from he is asking to write A2. The A2 is going to be 4°. He is asking angle of the prism in degrees only. It is going to be 0.54 upon 0.72. The 18 cancels out. 3 upon 4, 4 cancels out, so you can write it is going to be 3°. That means A2 is going to be 3°. If you see of these, the 4 is the right option. That means 4th is the right option for this question. Again, I think this is a very easy question. So if you simply know how to write my deviation, and if there is no net deviation, so if there is no net deviation, that means delta 1 minus delta 2 should be 0. Easy. Okay, let us proceed for the next question now, Bitte. So the question number next is question number 39. Here we are saying in the experiment for the measurement of the viscosity eta of the given liquid with a ball having radius r, consider the following statements. Again, it is a statement based. Read this thing, ki graph between the terminal velocity v and r will be parabola. Yes, I hope you can understand this is the right statement, because if you know how do I write my terminal velocity, so we can write v terminal is going to be, hopefully most of you may be remembering, this is 2 upon 9 r square rho minus sigma. Rho is the density of the body, sigma is my density of the liquid, into g divided by coefficient of viscosity. This is the formula for writing your terminal velocity for a body falling in a liquid of density. So I can say this is the liquid, there is a body has got some density rho, liquid has got some density sigma. In this case, it is coming down with its terminal velocity Vt. So as the question is being asked, graph between the terminal velocity V and R will be parabola. Obviously Vt is proportional to r square. That means y is proportional to x square. That means it is indicating a parabola graph. So it is a parabola. That means my A is the right option or right statement. Second, I am saying the terminal velocity of the different diameter balls are constant for a given liquid. Obviously not, because terminal velocity of the different diameters already you are saying is going to be different. So B is the wrong answer. C now let us come for the C. Measurement of the terminal velocity is dependent on the temperature. You know well, already we said that coefficient of viscosity is a temperature dependent quantity, as well as my density is also my temperature dependent factor. That means I can say yes, measurement of terminal velocity is dependent on the temperature. That means C is absolutely right statement. D, what he is saying here, this experiment can be utilized to assess the density of a given liquid. Yes, because it is depending on my density. If I want density here, suppose I know my terminal velocity of the two bodies coming in a liquid, If I know terminal velocity, I know the coefficient of viscosity, easily we can find what is my density of the liquid here. So yes, this experiment can be utilized to assess the density of the given liquid. Correct only. The D should be right one. If balls are dropped with some initial speed, the value of eta will change. Eta is an inherent property. It is the property of the liquid. It is not depending on what is the size of the ball. So that means balls are dropped with some initial speed, the value of eta will change. Obviously not correct. That means A is not correct here. So out of these, if you see A, C, D are the only three options which are correct. That means option 1 is the right option for this. So this is also very, very simple theoretical question. I hope you can understand it easily. So that is not a very difficult one. Let us try for the next question now. Here is the next question. You read it here again. We say a particle of the mass m and charge q is fastened to one end A of a massless string having equilibrium length L, whose other end is fixed at O. The whole system is placed on a frictionless horizontal plane. It is a horizontal plane. So main point, it is a horizontal plane. That means you don't have to worry about the gravity in this question, and is initially at rest. So he is saying there is some mass at point A which is at rest. If uniform electric field is switched on along the direction as shown in the figure, then the speed of the particle when it crosses the x-axis is what? Again, see beta, here we are writing q, so let me consider if q should be a positive charge. If q is considered to be a positive charge here in this diagram, if I'm mentioning this is my body here, let me say it has mass m, let me say it has plus charge q. If I switch on electric field in this direction, there is electrical force on this particle. It is fastened over here, and this electrical force, if I write, is going to be, you know very well, is going to be E into Q. This electrical force will try to deflect this mass. This electrical force will move this mass in this downward direction. The particle will move along the circular path because there is some component of force. One component of force is along this axis, another is going to be perpendicular to this line. So because of this component of force, this body starts moving along the circular arc. If it starts moving along the circular arc, when it is reaching here, he is asking what is the speed of this particle. Again, this is a very, very simple question if you use a work energy theorem. Here again we are saying in this question here you have to see particle is here, massless string, no mass of the string, whole system is placed on a frictionless surface. If it is a frictionless horizontal surface, that means no friction. We can easily apply either energy relations or you can apply work energy theorem. If I write by work energy theorem, so it is again easy for you to follow. So I write by work energy theorem. You know work energy theorem is saying what? Work done by all the forces acting on the body is equal to change in its kinetic energy. What forces are acting on the body? I can write delta W, there is no gravity. I can say there is a tension in the string because there is some force in this direction, and there is some tensile force. The work done by tension, I can say. I can write work done by electrical force. I can write work by electrical force. There is no gravity, nothing is there. It is inextensible string, so there is no elastic potentiality of this also. The work done by tension, work done by electrical force is equal to simply change its kinetic energy. Initially it is said to be at rest. That means my velocity here is 0. Here is the velocity how much he is asking. So I can write, and you know work done by tension is going to be 0. Reason, force and displacements are perpendicular. Body is moving along the circular arc. If the body is moving along the circular arc, then tension and this force, rather force and displacement being perpendicular, the work done by tension is going to be 0. Work done by electrical force, as you know, E is a constant factor, Q is a constant factor, force is going to be a constant value. The moment I am writing my force is going to be a constant here, so you don't have to worry about. Because if force is a constant factor, then delta W by electrical force will become F into displacement in the direction of force. We can write displacement in the direction of force. So if I write in the direction of force, how much is my displacement? Force is acting in the horizontal direction. If I drop a perpendicular from here on this surface, this angle in the beginning is going to be 60 degree. That means this distance is going to be how much? L by 2. It is L cos 60. Cos 60 is 1 by 2. That means once the mass has reached here, this total length is becoming L here. That means how much this mass has displaced in the direction of force. This is my force direction. The displacement direction of force is L by 2. So again, this is very simple. Work done is going to become my E into Q. So I can write now E into Q as my force into my displacement is going to be L by 2. So I can use now, it is going to be here EQ is force, L by 2 displacement, change in kinetic energy is half m into v square minus initially it was 0. So if I solve this question here, 2 cancels out from here. What is my velocity is under root of EQL divided by m. EQL upon m should be the answer for this. Is there any option here? Yes, this is the option number 4. So I can say yes, fourth is the right option. So this again is a very simple question. If you use work energy theorem with the electrical force, the main concept, force is constant, you can easily calculate the work done because of constant force in magnitude and direction both. Okay, so using this thing you can simply get this answer for this question. Let us move for the next now. Question number 41. Again, this is a question based on your ray optics. So this is the second question we are going to get in the ray optics. One they have asked on the prism, now it is there. Let us read the question now. Here we are saying a hemispherical vessel is completely filled with a liquid of refractive index mu. A small coin is kept at the lowest point O of the vessel as shown in the figure. Got it? The minimum value of refractive index of the liquid so that a person can see the coin from the point E, what he is saying. If you see here this question, I can see and just here is saying coin is at position O. If my coin is at point O, you want to see from here, your observer eye is in horizontal position. If it is horizontal position, that means the ray which is emerging out of the liquid is in horizontal direction. If I say it is my horizontal direction, the ray which is coming from this object, so it is coming from the object is reaching here. This is the incident ray which is reaching this point B. From here, if I draw a normal at this point, so what is my normal at this point? If I draw this as my normal. If you say this angle here from the diagram, emergent angle is going to be 90 degree. If this angle here is 90 degree and this being a rarer medium, that means this angle can be treated as my critical angle because this is the angle in the denser medium. So you know the condition for critical angle, whenever the light is going from denser to rarer, that's not a necessary. Whenever my angle in the rarer medium is 90 degree, then the angle in the denser medium will always be critical. So it is not necessary to say the light is going from denser to rarer, whether it is rarer to denser or denser to rarer. The only condition, if my angle in the rarer medium is 90 degree, then angle in this denser medium will become my critical angle. So at this surface, I drop this perpendicular. See the geometry of this figure? In the geometry of the figure, this is what R. Let me write R. That means these two angles are going to be equal. So I can say this angle is going to be 45 degree very comfortably. That means my C is going to be here. How much is 45 degree? If C is going to be my 45 degree, so this is what I can write now. There is a emergence in this direction, so you use the generalized Snell's formula. If I use my generalized Snell's formula, so using this generalized Snell's formula, so if I'm writing this thing, so using generalized Snell's formula, I can write it easily. In this medium, that is in the liquid, refractive index, let me say, is mu into, that is given to be C, and that is going to be here mu of air into sine 90 degree. Mu of air is taken to be 1, you know well. So if I write mu of air to be 1 here, that means C is given to be 45. So I write mu into sine 45 degree. It is going to be 1. That simply gives you this answer that mu is equal to under root 2 here. So here is what we are writing, the minimum value of my refractive index. So that means this is going to be my critical angle. So it is going to give you a minimum condition. I hope you understand this thing. So this is mu minimum is going to be root 2. So that means option 1 is the right answers for this question. Okay, so that is the question. Now let us move for the next slide. Again, there is a theoretical question. Question number 42. Given below are two statements. One is labeled as assertion and the other is labeled as reason. Okay, you know, reason, assertion, what we say. In a central force field, the work done is independent of the path chosen. You know, central forces are conservative forces. If I say my central forces are my conservative forces, and you know very well what is my conservative force, you know by conservative definition what is my conservative force. So I write conservative force is going to be, how do we define this? Conservative force Fc is equal to negative gradient of my potential energy. So from here also you can understand one more interesting point. Okay, this being conservative, central force is a conservative force. So this statement we know, central force is conservative. all these forces, gravitational forces, you're writing electrical forces, rather electrostatic forces, all these forces are going to be your central forces which are acting towards a fixed point and are inversely proportional to r square. So these are my central forces and they are conservative force. Conservative force is only the work done by conservative force, if I am writing, is my potential energy. The work done by conservative force is always independent of path. So if I write this thing, so it is always du is equal to f conservative into dr. If I am writing in this manner, integral of this is going to give you total change in potential energy. Negative of the change in the potential is the work done. So if I write this is my work done, so I can write minus delta W in this manner. So minus delta W by conservative force here. The work done by conservative force is independent of path. That means here we are writing in a central force field, the work done is independent of the path chosen is correct only. That means A is the right option. Every force encountered in the mechanics does not have an associated potential energy. Just now we said, if my forces are going to be conservative, the potential energy is well defined only for what is well defined for conservative forces only. But in nature, all my forces need not be conservative. If there are non-conservative forces, that means the potential energy is not a defined quantity. The potential is well defined for conservative forces only. Very obvious. This means this second option as we are writing, every force encountered in the mechanics does not have an associated potential energy, is absolutely correct. This is also correct statement. That means A is also correct. Reason is also correct, but whether the reason is explaining the question assertion or not is a question mark. Obviously these two statements are here, we are writing it is potential energy, I'm talking about work done is conservative force. The A is correct, R is correct, but it does not mean it is explaining A also. So both A and R are true and R is not the correct explanation, because this is a definition of conservative force. Simply it is defined by conservative force, not because of the first central force. If it would have been conservative force here, then we can say yes, both may be correct and it will be explaining that also, but both A and R true, but R is not the correct explanation. So according to me, this option 4 should be the right answer. So here 4 should be right answers, because it is not saying, second statement is talking about conservative forces, it is talking about central forces. No doubt my central force is a conservative force, but even then try to understand this A and R both are true, but R is not the correct explanation for A. So this is again theoretical theory based question. Now let us come for the next question. Here he is saying a wire of resistance R is bent into an equilateral triangle and an identical wire is bent into a square. The ratio of the resistance between the two end points of the edge of the triangle to that of the square is very simple question. You know, in this case, what he is asking, I think this is the easiest question again from the current electricity part here. As you know, resistance of the wire is given as rho into L upon A. He's saying you are using the same identical wire, you are using identical wire, so I can say resistivity and that length, area, everything is going to be same here. But resistance is proportional to length. If I break my wire into an equilateral triangle, my length has reduced to 1/3. That means if I reduce my length to be 1/3, that means it is L upon 3. So equivalently, I can write this resistance is going to become R by 3. He is asking the ratio of the resistance between the two end points of an edge of a triangle to that of a square. If I write this here, this is going to be R by 3, R by 3, R by 3. So these two R by 3 are going to be in this manner. R by 3 is in this manner. These two are connected in parallel. That means if I write R for the triangle, if I am writing about the two ends, it is going to be R1, R2. That means I write R by 3 into 2R by 3 upon the sum of the resistance is going to be R only. So I can write it is going to be 2R divided by 9. Similarly, if I break into this square part, and then square, it has got all four lengths to be equal. That means this length is becoming R by 4, this is becoming R by 4, this is becoming R by 4, this is becoming R by 4. So if I'm writing all these distances as R by 4, that means all these three are again in series. If these three are in series, so what else we can say about it? That means this is going to be 3R by 4 as one resistance, and the resistance is coming out to be R by 4. these two resistances are connected in parallel. So if I write what is my equivalent resistance of this square, so that is going to be how much R1 R2, you know very well. R1 R2 is going to be 3R by 4 divided by R again. So what is this value? I can write 3R upon 60. He is asking the ratio of the triangle to the square. That means we get this easily, R triangle upon how I'm writing R of this square part. So if I'm writing this square part here, so anyway you can get it here. So this is going to be something 2R by 9 divided by 3R upon 16. Since R goes out, 16 into 32 upon 27. So 32 upon 27 should be the right option for this. So you can say option 4 is the correct option for this question. So 4 is the right answer for this. Again, you can see this is going to be a very simple question in this paper. The only thing is that you should understand this R is proportional to length. If R is divided into 3 parts, R by 3 will come. I take these 2 points as my end points. These two are in series. These two combined are going to be in parallel. Anyway, let us go for the next question now. So if I go for the next question, oh, this question on the nuclear physics again is a straightforward question. Choose the correct nuclear process from the given below. It is a neutron. When it's converting into proton, it is a beta negative decay. So beta negative decay, if I'm writing, so in this case what we say, your neutron is converting into proton and is generating an electron. That's why you call it as a beta negative decay. And with electron, I'm getting an anti-neutrino. With positive decay, we get positron and a neutrino, but here it is neutron is converting to proton, so it will generate. So it is a straightforward reaction. So I can say neutron is 1 and 0 is converting into 1p1, and then I can write is electron. It is going to be how much? It is going to be 0 minus 1, and then I'm writing it is going to be neutrino. So I can write minus 1, here it is 0, and then I'm getting anti-neutrino. That's why I'm balancing all nucleons in this way. This anti-neutrino, must be knowing the conservation of angular momentum. Spin angular momentum is also to be conserved. Because of that, we are getting this factor over here. So to conserve this thing, we are getting an anti-neutrino here. So I can say this is the straightforward question. So I don't think there is more explanation in this. It is a straightforward question. So fourth is the right option for this question here. So neutron is converting proton and an electron and an anti-neutrino. So that is another simple one. Let us go for the next slide now. Let us come for the question number 45. Here we are saying this one, you see this question, consider a long, thin conducting wire carrying a uniform current I. A particle having mass m and charge q is released at a distance a from the wire with a speed v0 along the direction of current in the wire. Okay, the particle gets attracted to the wire due to the magnetic force, very obvious. The particle turns around when it is at a distance x from the wire. So he is saying when particle turns around, when it is at a distance x from the wire. This question I think is one of the best question in this paper that they have asked. This question can be solved in different ways. Okay, one thing is there is a very conventional method, because if you see this thing, there is some infinitely long wire. Let me try to explain this question. Okay, just see, this question is a very interesting question here. I'm trying to use a different methodology to solve this question. Here we are saying there is something like I is the current flowing into this. It is denoted by capital I, not an issue. Okay, capital I is the current flowing into this wire. A particle having mass capital M, I'm not bothered because in the answers they are writing small m or something like that. So there is something like, suppose I say there is some mass here. So if I say m is the mass and charge q, if you say there is some mass, it has some charge positive q, let me write its mass is m. Now you listen this question very carefully, how we are proceeding for this question. Okay, I'm not following this question in a very conventional method, because with conventional methods you can solve a very long solution for this question if you go by a conventional methodology. Conventional methodology, what I'm saying, if you see this parts, first of all, he is saying it is projected in this direction. See this question. Let me say it is projected in this direction from a wire with a speed v0 along the direction of current. So let me say current direction is up. Projecting this particle with a velocity v naught in this direction. If v naught velocity is given to this particle, you know the force which is acting on this is F into Q, QVB, or you're writing Q into V cross B. Because of this wire, at this point, your magnetic field direction is in the downward direction. Easy. V is in upward direction, B in the downward direction. V cross B, if I use the V cross B, is going to give you force towards the wire. That means that's what he's saying, this particle starts attracting towards the wire. So he's saying current in the wire, the particle gets attracted to the wire due to the magnetic force. Absolutely correct. So this is going to be now magnetic force at this position. And this force is trying to move. The interesting part of this question, whether it will follow a circle of constant radius, obviously not. Reason, because B is a variable factor here. If B is a variable factor, so we can say the particle will be moving somewhat in this manner, maybe moving in somewhat direction. What he is asking in this question, when this particle turns around, that means it is maybe moving somewhat in this way. So when it has reached this position, at this position, this distance, what he is saying in the question is A. At this position, he is asking, this position is given to be X in the question, X. He is asking what is this value of X when it turns around in this manner here. Now the interesting part of this thing, what? You know, as magnetic force is always perpendicular to the velocity factor here, so since we are saying force magnetic is perpendicular to velocity, that means work done by magnetic force will definitely be zero, no issue in that. What we can understand from here, because there is no other force acting on this body. If there is no force acting on this body except my magnetic force, you know, it is going to be nothing but what? Delta K. So what we can say from here, that my speed of the particle will remain constant, that is V naught is constant. You go at any point on this part, motion of this path or the path of this particle, so every point of this path, velocity of the body is V naught only, magnitude wise. So if magnitude V naught is going to be constant, so how I am writing this thing? They say if you reach somewhere here, let us say you have reached to this position, your particle has gone to this position. We know again my velocity of this magnitude is going to be V naught only. But who is moving this particle in this direction? If you understand, then I can use just Newton's law as F is equal to dp upon dt, and we can get the solution of this question in an easy way. I can write, if this is my velocity v, let us look for this velocity component here. You see, see, this is going to be its x component of velocity. Let me say this is going to be y component of velocity. I'm saying if you see the particle has reached somewhere here, which velocity of this particle is going to change? See here, obviously now Vy is also there, Vx is also there, my V naught is constant, so V naught is constant as Vx square plus Vy square. And if I write V naught is square is equal to Vx square plus Vy square, and then by writing my force relation, I can solve this question. That is very lengthy approach of solving this question. But see what I am saying. Who is changing this velocity in the downward direction? Which velocity component is generating this force? If you write for velocity in y direction, so if the velocity is in the y direction, then the magnetic force, because the velocity in the y direction, b being always in the downward direction, velocity is in the upward direction, that means force is in horizontal direction. So there is a horizontal force which is trying to move this particle towards the wire, and there is a component. If you just look for Vx, due to Vx, the magnetic force is acting in the downward direction. This force which is acting in the downward direction, trying to pull this body in the downward sense. So which force is responsible here to change Vy? No doubt, Vy is also turning, Vx is also turning. But if I am writing this force because of Vx, if I write F magnetic because of Vx, so magnetic force due to Vx, if I am writing, is in downward direction, is in, suppose I consider this to be x direction, this to be y direction, I can say is in negative y direction. I hope, see this question very easily. See it, I'm writing Vx everywhere. If my particle is here, or when the particle is going at any position, I can write it has got Vx component, and I get now my Vy component. Vy component, Vy is reversing its direction, but my Vx is not reversing its direction. If Vx is not reversing in direction by the time it has come to this position, what I can say, my magnetic force is constantly acting in the downward direction because of my this x component of velocity. So I can say now if magnetic force due to Vx is in negative y direction, so this is now my F magnetic due to which velocity is Vx. If I am writing F magnetic, I will be writing now it is going to be Q V B. Let us say at this point I am there. So at this point, let me say for the time being, I just use the same notation. Take this to be x here. Here I am just changing my notation. I just change it to be x dash because what the question is saying x, I will change it later on. So what I am saying, if my x is a variable factor, because I have to choose x, my because b is a variable quantity, I will write f qvb. What is f value? You know, f is equal to q vx b at this position, you know, b due to infinite long y mu 0 upon 2 pi. This is I divided by x. We know by definition this force is because of my velocity Vx acting in the downward direction. So I can write now F is equal to this value, and this is going to be nothing but what? dP divided by dt. This force is acting in the downward direction, so I can say it is going to downwards. So if I consider upward as my positive, downward as my negative value, I can choose this is going to be negative here. So being these vector factors, vector quantities, so I write now dP is equal to, it is q mu naught I divided by 2 pi Vx dt. I hope you got it. Here you can see it looks like impulse momentum, but I won't say it is impulse momentum because it is not impulse. It is a constant acting force here. So it is, I am writing now F is this quantity into dt is dP. Now look for the directions carefully. F is in the downward direction. Change in the momentum, if I am writing, I integrate it. If I am integrating dP is nothing but what? I can write m into final minus initial, no issue. I am writing Vx dt. Here is a clue here. Vx dt, if you look for, one thing I am writing, my velocity, force in the downward direction. As force in the downward direction, I am considering downward direction, I am considering it to be positive because my force is always in the downward direction. So I will consider this to be my positive direction. If I consider it to be positive, then I'm not changing the sign over here. So I keep this sign as my positive value. So I'm not changing this sign, keeping it positive. Initial velocity is in the upward direction. This is my V initial. Finally, once you're writing the body has come down, it is V final is again going downward. It is going to be minus V naught in this manner. Since downward I am considering positive, so I will write this is going to be my positive velocity and this is going to be my initial velocity V naught. If I am writing dP, 3p is now m into final velocity minus initial velocity. So if I write this here, so I simply put m, final velocity is v naught, initial velocity is minus v naught. So I write minus v naught. It is my change in the momentum by the time the body has gone from this position to this position. So I'm writing directly between the positions 1 and 2. If you see these two positions, so I'm just using some different ink. Here is my position number 1 and I'm writing it is my position number 2. So it is P1, I'm writing it is V1, I'm writing it is going to be m into V2. So it is m into V2. Be careful, V2 downward positive, V1 upward is negative. So I'm writing this relation in this manner. Get it here, m into V naught minus V naught. I hope you got it this easy. This is the change in the momentum. This is going to be now integral of all these factors are constant. You just see here mu naught qi is constant. So I write mu naught upon 2 pi. I can write qi, that is constant. Then I write my Vx into dt. Vx dt is now, if I write this thing here, so Vx in the left hand side direction, as I'm saying, Vx is constantly acting towards left hand side direction. Vx dt is nothing but is going to give you dx, but dx is on the left hand side direction, so this quantity is going to be dx, but being on the left hand side direction, I can write a minus sign here. So I can use as a minus here. The moment I am writing this thing, so it is some factor I have missed over here, it is 2 pi x is there. So I will write it is dx divided by x, because x cannot be taken out of this integral. So dx upon x is the factor. So what you got it here from? So you just see, I'm getting a minus sign here. I'm getting it is m into 2 times m into v naught is going to be mu naught upon 2 pi qi. Vx dt we said is going to be minus dx. So I put a minus sign here, dx upon x. And x in changing this going from where to where is going from a to x. If I write this thing is going to be mu naught upon 2 pi q I, it is going to be log of x upon a. I hope you got your answer from here. I'm just writing x here from here. So this simply implies what? You just see here. So in this case, if I write log x upon a, I hope it is all obvious from you. Your side, that is log of x upon a is going to be something. It is 2 into 2, it is 4 pi. It is already a minus sign, so I put a minus sign here. I will write it is 4 mv naught. So 4 pi mv naught, 4 pi mv naught divided by mu naught into q into I. There is a minus sign, so I put a minus sign here also. So this simply implies what? X is equal to a times exponential of minus of, what is this is written here, so I can write minus of 4 pi mv naught divided by mu naught into qi. That's the value. So that means option 4 is the right option for this question. Try to understand this question in a very simple way. Just see what we are writing and how we are proceeding in this question. If you use this relation, otherwise the solution of this question is a very, very long solutions. But try to learn this methodology, how we are using this force relation. So I'm writing now F is dp upon dt. Using from this dp upon dt, be careful about the directions, how I'm writing my direction relations. Momentum, it is written in this way, Vx, Vx, Vx. The Vx is always like this. Which component of force is changing its direction in the y direction is the force because of Vx. So I'm writing the force because of Vx in the downward direction. Take this F, use dp upon dt. I hope you enjoyed the solution of this question in a very simple way. So that way if you proceed, but this question definitely is a very, very good question. That is what asked over here. But this question is definitely up to your advanced level. But anyway, they've asked at your mains level. Okay, let us, I hope you must have enjoyed. Let us go for the next question now. Question number 46. These are some numerical based problems. So what he is saying here, just read it again. Two iron solid discs of the negligible thickness have radii r1 and r2 and moment of inertia I1 and I2 respectively. For r2 is equal to 2 r1, the ratio of I1 and I2 would be. See here in this question, one thing he is saying iron, that means the material is same. Negligible thickness, okay, no problem. You can consider thickness to be negligible, so you can write mass is proportional to the area, not an issue. So if I write this mass value here, so I can write first thing, mass density. If I write for the two spheres in the question, what he is saying, mass density sigma 1 is equal to sigma 2. Okay, 1 sigma 1 is equal to sigma 2. You can write now mass. Mass is equal to sigma into area, because sigma is nothing but what? Mass per unit area we are writing. If I'm writing this dm upon a, so m is going to be a sigma 2 are constant, so I can write sigma into area. Area is nothing but what? Pi r square. Here we are writing this I1 and I2 as my moment of inertia. Let us say, suppose I write this is one disk. Its moment of its axis is not defined. I hope axis should be taken to be same here. He is saying R2 is going to be 2 R1. So if I consider this is another disk, it is R2. R2 is going to be 2 R1. I choose the same axis. This axis is given I1. This axis is given to be I2. He is asking ratio of I1 upon I2 is being asked. For a disk about its axis, you know very well, I1 is half of m1 into r1 square. Similarly, I2 will become half of m2 into r2 square. So this is again a very, very simple question on the moment of inertia on the mechanics part here, you know well. So I can write now I1 upon I2 is going to be m1 into r1 square upon m2 into r2 square. But already you see here, mass is proportional to square of the radius. If I write m1 upon r2, I will write it is going to be r1 square upon r2 square, so it will become r1 to the power 4 upon r2 raised to the power 4, or I can write r1 upon r2 whole raised to the power 4. If r1 and r2 in the question is given, r2 is equal to 2r1, so I can make it as 1 upon 2 raised to the power 4. Obviously it is becoming 1 upon 16. He's asking what is this value of 1 upon x. So if I write 1 upon x from here, very obvious, x is equal to 16. So this is going to be right answer for this question. So for question number 46, option should be 16 here. Okay, I hope all of you can solve this question. So there is also a very simple question, just formula base. Let us go for the next slide now. Question number 47. Again, it is a moment of inertia question. Oh, they have asked similar question on it here. So in the whole paper, these again they are asking repeatedly the question on the same topic. Two questions on current electricity. Now similarly they are asking two questions on the moment of inertia. So anyway, it should be a balanced one anyway. So here we are writing the moment of inertia of the solid disk rotating along its diameter is 2.5 times higher than the moment of inertia of a ring rotating in a similar way. Here one thing, he's saying if I consider moment of inertia of a solid disk, okay, let me write there is a disk. He is asking about diameter. You know, moment of inertia of a disk about diameter we know very well. It is 1 upon 4 times m r square. Because about the axis, you know, it is going to be half mr square. If I use my theorem of perpendicular axis, being moment of inertia about these two diameters equal, anyway, you can understand I diameter is 1 upon 4 times mr square. He is saying moment of inertia of the solid disk rotating along its diameter is 2.5 times higher than the moment of inertia of a ring rotating in a similar way. If I write my ring here, for the ring, if I consider this to be my ring here, it is rotating about its diameter. Let me write it is I of the ring here. If moment of inertia of the ring I am writing about the diameter, it is going to be again half m into r. For the ring I write r square. It is what I write r for disk square. At last, you can see in the question it is given that consider all the bodies have equal masses. So I'm not changing my mass relation. I'm keeping mass here m and I'm keeping mass here as m. This is what in the question he is saying. The moment of inertia of the disk is 2.5 times higher than the moment of inertia of the ring. So it's very easy. I write 1 upon 4 m into rd square. 2.5 means I can write it as 5 by 2 times. It is going to be half m into r for the ring square. Mass being equal can cancel out. 4 is also cancelled out. I can write straight away this relation rd square is equal to 4 times r of the ring square. I get one equation because he is not giving you the relation between diameter, the radius of the ring and disk. Anyway, next what he is asking, the moment of inertia of the solid sphere which has the same radius as the disk. Okay, now you are considering a solid sphere. Okay, in this solid sphere I considered it again its diameter. He is saying this sphere has got, it is a solid sphere, he is saying. Okay, so for a solid sphere, if I am writing this radius of the sphere is given, I denoted by rs, is equal to same radius as that of the disk. That means r of the sphere is given to be equal to r of the disk. In a similar way, is n times higher than the moment of inertia of the given ring. So just see what we are writing, I of the solid sphere is nothing but what? N times higher than the moment of inertia of the given ring. So I can write I of the ring. Now if I write I of this, so he is asking what is the value of n. I hope it's again very simple question. I for the solid sphere, if I write this I of the sphere, you know, it is going to be 2 upon 5 times mass. Again, I am considering it to be same. The m into r of solid sphere square I write. Okay, so what is the question here? N is becoming nothing but what? 2 upon 5 m into r of the sphere square divided by I of the ring. I of the ring you have already said. It is going to be 1 upon 2. It is m into r of the ring square divided by 2 here. So what we are getting it here as such. We can write it is going to be cancels out. I can write it is 4 divided by 5 rs square divided by r of the ring square. We are already done with rd square and rr, and the question is also saying rs is equal to rd in this thing. So if I say rs is equal to rd, so I can write 4 upon 5 rd square upon r of the ring square. Here you know rd square is 5 times rr square. If I write rd square is equal to 5, yeah, rather 5 rr square is rd square, so obviously n comes out to be 4. That means this n should be 4. So the correct answer should be 4 for this question. So again, not a biggie question, simple question. So you can proceed. But be careful what the notations are being used. It is very easy for you to get this. Now let us go for the next question. That is question number 48. Oh, it is question based on your wave optics, Young's double slit experiment. They are saying a double slit interference experiment performed with the light of the wavelength 600 nanometer forms an interference fringe pattern on a screen with 10th bright fringe having its center at a distance of 10 millimeter from the central maximum. Okay, so as you all know, let us try to proceed. If I consider this as my Young's double slit experiment, it is my single slit, it is my S1, it is my S2, this is my screen. Let us consider some with large distance. Distance of center. Now we are saying here is a 10th bright fringe. So he is saying bright fringe, the 10th maxima is at a distance of, if I denote it by y and I am writing 10th maxima, the y10 is given to be 10 millimeter. We are using the wavelength here. It is given to be 600 nanometer. So once we are using lambda, it is there. I hope you must be knowing if I write my part difference over here, what is my part difference in the situation? We can find all this my part difference. If it is going to be d, if this angle is theta, you can all understand this angle is going to be theta. I hope this is what must be understanding. If this angle is theta, because if this capital D is taken to be much larger than d, all these rays are assumed to be almost parallel, then we can say if this is theta, this is theta. So, you know, if you remember the formula also, what we write, part difference for nth maxima, delta x is equal to, this distance is, angle is theta, so this part difference is d sine theta. So I can write now d sine theta, but theta being a very small quantity, I can make it as d tan theta, and if I write tan theta, so I can write now it is yn divided by capital D. So my what is delta x is going to be d into yn upon capital D. You know, for nth maxima, it is going to be n lambda. That is what we write for nth maxima. Okay, question is demanding for 10th maxima, so not an issue. We can make n as 10 here. I can write now yn is depending on n times capital D lambda upon small d. Here you understand this thing now. He is saying distance of the, see, 10th bright fringe of the central, he is simply changing the wavelengths. Okay, if he is changing the wavelengths, you know y is depending on lambda. He is not changing my n. He is saying 10th bright fringe from the maximum for this wavelength, and this is also 10th bright fringe here also. So I can say I don't want to change my n. N is same. Lambda is going to be different here. Capital D, small d, I keep it to be same. That means what I can write, yn is proportional to straightforward lambda. If yn is proportional to lambda, I can write it easily. Y in the first case, y10 in the second case, I write 2, no problem, is in the first case is going to be lambda 1 divided by lambda 2. Lambda 1 is given to be 600 nanometer, lambda 2 is given to be 660 nanometer. So it is going to be 1 upon, how much is the value? 10 upon 11 rather. So 10 upon 11 is this value. I hope you can understand why not 2 is going to be how much? That is 10th bright fringe for the second wavelength is going to be 11 upon 10 into y01. Y01 is given to be 10 millimeter. So I write again into 10 millimeter. This cancels out. What is the value? 11 millimeter is the position of your 10th bright fringe from the central maxima. This is the position of central maxima here. So this is what we are asking. So 11 should be the answer for this question. Again, I can say yes. This one is simple. Yes. Again, it's just a formula based question. So you know the formula. Yn is how much? If you remember this formula, this question can be solved very easily. Okay, let us go for the next question now. Question number 49. He is saying in a measurement, it is asked to find the modulus of velocity per unit torque applied on the system. The measured quantity has a dimension, so it is a dimensional formula question. So it is writing m a l b t to the power c. If b is 3, the value of c is equal to how much? Okay, no problem. In this question, what he is asking, modulus of elasticity per unit torque. So what the quantity what is he's asking, then let us say the physical quantity P is nothing but what he is saying is, I can write some proportionality constant if you want, is modulus of elasticity per unit torque. So it is modulus of elasticity, let me say Y or Young's modulus, not necessarily any elasticity, divided by torque. Elasticity, you know, is going to be stress divided by strain. Strain we know very well has got no dimensions, divided by torque. Stress we are writing is as force into area, divided by torque you are writing as force into some factor as length here. That means if I write my physical quantity, so what is my dimensional formula of the physical quantity P is written as F cancels out. A is going to be L square upon, so what you're writing, tau is going to be, yes, stress is, I'm sorry, force upon area, that is upon area, so it is going to be 1 upon A into L. If I write 1 upon A into L, so that is nothing but what? 1 upon L cube. So I can write it is going to be m to the power 0, L power will become minus 3, and m, L and T, if I write, is going to be 0, because there is no time factor, there is no mass factor, only length factor. But in this question is giving B is 3. Anyway, I think there is some mistake in this question, because B is given to be 3, but actually it should be minus 3, because if I consider B to be, if I consider my B to be minus 3 here, then obviously C will come out to be 0. So the correct answer for this question is value of C is asking, so C should be 0. So again, it is a very simple question, no nothing, simply use the dimensional formula, we can get this question solved comfortably. So this 49th question. Let us proceed for the next question, that is the last question of this paper, hopefully. So let us go for the next slide. Oh, see, here it is. This is what, let us read again. A tiny metallic rectangular sheet has a length and width of 5 millimeter and 2.5 millimeter respectively. So he is saying length and the width are given to you. So I am writing length and the width of this. There is a sheet here. Length is given to be 5 millimeter. And the width is given to be, simply saying it is 2.5 millimeter. What else is asking? Using a specially designed screw gauge which has a pitch of 0.75 millimeter and 15 divisions in the circular scale, you are asked to find the area of the sheet. In this measurement, the maximum fractional error. So it is an error based question. Anyway, you know, if I write my area, he's asking what is my fractional error in the measurement of area. Okay, so we are measuring area here. Area is nothing but what? L into B. In this case, if I write what is my fractional error in the A, you know the purpose, methodology, you know, I take the log on either side. Log A is equal to log of L plus log of B. If I differentiate term by term, I can write my dA upon A is equal to dL upon L plus dB upon B. This is the way to write your fractional error in area. So this is now fractional change, that's what he's asking, the fractional error in area. But we should understand what is my DL and DB. DL and DB are the errors, that is what can be committed in the measurement of any physical quantity, that is length and width. Because length and width are measured, both of these two values are measured with a screw gauge, and a screw gauge, whatever is my least count of the instrument, is going to be the maximum error, that is what is committed in the measurement of the physical quantity. So if I write here what is my error in the measurement, the error in measurement of the error in measurement of L as well as B is nothing but what is the least count of your screw gauge. And how do we write the least count of the screw gauge? It is what you know, it is pitch divided by number of divisions on my circular scale. So if I write number of division and pitch is given to be nothing but what? 0.75 millimeter. Number of divisions in the question are given to be 15. That means it is going to be 0.05 millimeter. So how much is the error permissible in the measurement of length as well as width? Is 0.05 millimeter. That means if I write my fractional error in area, so dA upon A, DL and DVs are going to be now 0.05. So I write 0.05 millimeter divided by length is also given to be 5 in same units, no issue. dB is again 0.05 divided by B is going to be 2.5 here. It is again in the millimeter, so this will become 0.01 plus 0.02, so it becomes 0.03. He is asking in terms of x upon 100, which is what can be written as 3 divided by 100. I hope it is correct. Yes, that means the value of x should be, therefore in the question what you're writing, it is denoted by x upon 100. So obviously x is going to be 3. So your answer should be x is equal to 3. So this is the complete solution of this paper. So we can understand, yes, paper more or less is going to be very easy, I will say, except two questions in this paper. One question which was based on your electric potential, that was a good question, and there is a very good methodology, that is what we have used in finding out at what distance upcharged particle is going to change its direction if B is a variable factor. Use these things. I hope you must have enjoyed solving this paper. Okay, that's all for today. Okay, thank you.